Hi students, I'm the CEO, Authority Educational Consult, giving you the best. Today, we shall be looking at chemical equilibrium. What is chemical equilibrium and how is equilibrium be attained in a chemical reaction? And solve some specimen questions at the end of this class. Now watch. During chemical reaction, the reactant will be producing the product. A point will come when the concentration of the reactant and the product no longer changes with time. When the coin of reactants and the product no longer changes with time, we now say that a dynamic equilibrium has reached. On that note, the rate of our forward reaction become equal to the rate of our what? Reverse reaction. So when the rate of the forward reaction become equal to the rate of the reverse reaction, a chemical reaction is said to be at equilibrium. What am I saying? I'm saying that a chemical reaction is said to be at equilibrium under many conditions. One, when the rate of forward reaction is equal to the rate of the reverse reaction. Then two, when the concentration of the reactants and products no longer changes with time. That is, when the change in concentration of the reactants and product become equal to zero, we now say that equilibrium has been established. Then three, when delta G become equal to zero, delta G stands for what? Give free what? Energy. Four, when change in H become equal to T change in X. Change in H represents change in enthalpy. T represents temperature. And change in X represents change in entropy. Most point on that, when the equilibrium constant K become equal to 1. On that note, a reaction is said to be at equilibrium. Now let's proceed. We're now going to look at the law of chemical equilibrium. And the law of chemical equilibrium is called what? Class. Guess what? The law of chemical equilibrium is called the law of what? Mass action. It's called the law of what? Mass action. And the law of mass action states that the rate of chemical reaction is proportional to the algebraic product of the concentration of reactants. Each of the reactants raised to its coefficient in a balanced equation. Say it again. The rate of a chemical reaction is proportional to the algebraic product of the concentration of reactants. Each of the reactants raised to the power of its coefficient in a balanced chemical equation. The law of mass action enables us to write the equilibrium constant as you can see on the board. AA, y small a is the coefficient plus bb, y small b is the coefficient plus cc, y small c is the coefficient plus dd, y small d is the coefficient. Now if you write the equilibrium constant, the equilibrium constant K is given as concentration of product raised to its coefficient divided by what? Concentration of reactant raised to its coefficient. On that note, two reaction are there because two is a reversible reaction. To and what? Fro. A chemical reaction, a chemical equilibrium is a reversible reaction. It moves what? To and what? Fro. Which means that K1, I have K1 and K2. K1 is now CC plus DD while the small c and small d are coefficient, and AA dot BB, while small a and small b are coefficient. In K1, which is the equilibrium constant for the forward reaction, C and D are what? The product, are what? The numerator, while A and B are what? The denominator. K2, in K2 we have AA plus BB, AA BB divided by what? CC DD, while small a and small b, small c and small d are what? Coefficients. On that note, compare K1 and K2. Compare K1 and what? K2. You notice that K1 is reciprocal of K2, which implies that both of them are inversely what? Proportional. As K1 increases, K2 does what? Decreases. If equilibrium constant of the forward reaction increase, that of the reverse reaction does what? Decrease. And the note share, this is a typical exam question. What is the connection between K1 and K2? K1 and K2, the product of the two equilibrium constant is 1. The product of the two equilibrium constant is expected to be 1. That is K1 times K2 is equal to 1. Now let's proceed to some example. If I have nitrogen gas plus hydrogen gas to give us ammonia gas, state of the system is specified: gas, gas, gas. The equilibrium constant of that equation is going to be what? Product raised to its coefficient divided by what? Reactant raised to its coefficient. From the equation now, what is the product? Ammonia is the product. So we have ammonia raised to its coefficient 2 divided by what? Nitrogen dot hydrogen raised to its coefficient. Remember that the coefficient of nitrogen there is 1. So on that note, that is the equilibrium constant of this expression. Remember that the state of the system is gas, gas, gas. So nothing happened to the reaction. Then question 2. Calcium carbonate, solid, give us calcium oxide, solid, plus CO2 gas. Students should note that calcium carbonate is solid, calcium oxide is solid, and CO2 is a gas. So the state of the system has been specified. The equilibrium constant of that expression is product over what? Reactant. Product raised to its coefficient over reactant raised to its what? Coefficient. So in that note, we have concentration of calcium oxides multiplied by concentration of carbon 4 oxide CO2 divided by what? Concentration of calcium carbonate. Remember that calcium oxide is solid and calcium carbonate is also what? Solid. Students should note that the equilibrium concentration for solids is always constant. They are not involved during equilibrium constant expression. On that note, the only concentration there is CO2 gas. So equilibrium constant K is what? CO2 what? Gas. While the concentration of calcium oxide solids and calcium carbonate solids has been neglected because there is no change in volume of solid when compressed.